Here's our question. We're told sine A equals p over 2 with both A and B acute angles, and that the compound angle expression on the left equals 2p. We need cosine A and sine B, each in terms of p. The given data, sine A and the compound angle equation. Our targets, cosine A and sine B, both in terms of p. So here's what we're working with. Sine A is p over 2, the compound angle difference equals 2p, and we want cosine A and sine B. The key insight for part A is to draw a right triangle. Since sine A equals p over 2, that tells us the opposite side is p and the hypotenuse is 2. With two sides known, Pythagoras gives us the third side, and then we can read off cosine A straight from the triangle. Section 1. Find cosine A from the right triangle. We know the opposite side is p, and the hypotenuse is 2. Pythagoras' theorem says adjacent squared plus opposite squared equals hypotenuse squared. Rearranging to isolate the adjacent side, edge squared equals 4 minus p squared. Take the positive square root, since we're in an acute triangle. Cosine is adjacent over hypotenuse. Root of 4 minus p squared, all over 2. Section 2, Part B. Let's expand the compound angle expression. The compound angle formula for sine. Sine of a plus or minus b equals sine A cosine b plus or minus cosine A sine b. Apply the formula to both terms in the difference. The first term, sine of a plus b, expands to sine A cosine b plus cosine A sine b. The second term, sine of a minus b, gives sine A cosine b minus cosine A sine b. Then we subtract the whole bracket. The sine A cosine b terms cancel out, and the two cosine A sine b terms add up, leaving 2 cosine A sine b. Section 3. Now set that equal to 2p and solve for sine b. From Section 2, sine A plus b minus sine A minus b equals 2 cosine A sine b. That equals 2p. Divide both sides by 2. Substitute our result for cosine A from Part A. Rearrange. Multiply both sides by 2 over the square root, and sine b equals 2p over the square root of 4 minus p squared. Final answers. Part A, cosine A equals the square root of 4 minus p squared, all over 2. Part B, sine b equals 2p over the square root of 4 minus p squared.